And good morning, good afternoon, good evening, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon. I am a 3D printing variety streamer here on Twitch. Glad to see everybody here. Let's see, who do we got here? We've got Icarus Links, welcome on in. Project in Dan's Garage, how's it going, sir? I am sorry I missed your stream this morning. Evil Diesel 3D, Waters, and Clover were over at the house today. So had a lot going on. Hey, Big Jana, welcome in. JD Montgomery, how's it going? Hey, Blue Chocobro, how's it going? I cannot hear you. Oh, it was on your end. Gotcha. So first off, I want to say happy, haven't had enough coffee yet today. Happy Veterans Day to all my fellow veterans out there and those that are actively serving. I hope everyone's having a good day and taking advantage of all the great deals that were out there. And if you didn't get a chance to partake, that's okay. I tend to just kind of stay at home and chill out and, you know, just enjoy it. But welcome on in, everybody. Hey, multi-headed Voron, how's it going? Pezlis, how are you doing today? And thank you. Yes, words are hard, Tulsa. Words are hard sometimes. Hey, Liz, how's it going? I hope you're doing well. Great big hearts back at you as well. Hey, Built Over Bot, how's it going? Any day you can hide from the world is a good day. Yep. Give me 1 second to step off the screen here. So as I mentioned, we had Waters and Clover from Ecovate 3D. They were over here visiting. They've been trying to get out to the Dragon's Den for quite a while. They finally got the opportunity to. Hey, Eagle the Dragon, welcome on in. And thank you for the Happy Veterans Day. I appreciate it, buddy. Sorry I missed your call earlier. We had Evil Diesel and Waters and Clover over at the house today. They just had a lot going on. Give me 1 second, folks. Sorry about that. Speaking of veterans, that was my brother. Him and his wife are formerly active duty Marines. So, but thank you all. I got, I think this is 30 presents. I'm not sure what the reference there is from Black Rifle Coffee Company, but kind of had a Santa, a Christmassy theme on the box. But I just needed a cup to keep me going until Mrs. Dragon gets home with some Dunkin'. Yes, happy Veterans Day, everybody. Funny story. So yesterday I was sitting there needing to set up some meetings. So I'm sitting there setting up meetings. And finally somebody says, hey, tomorrow's Veterans Day, like a day off. And I had to chuckle to myself because if you're active duty or a veteran, yeah, Veterans Day is just another day of work normally. And if you're not working, you're wishing you were working because it probably means that you're standing in formation somewhere doing a dog and pony show for something. So yeah, me and Evil Diesel have been having a hard time all day today just because we're used to having something going on. But yeah, welcome on in. Hey, Strip Father, welcome on in. Martin, hope you're doing well. Along with all the other veterans and active duty members here today. Yeah, thank you. I appreciate it, multi-headed Voron. Currently looking into light options for the holiday light show project. Well, there you go. Hey, Waters, long time no see. I was mentioning that you and Clover were over here today checking out the Dragon's Den and just kind of going, oh, crap, he was right. There's like 1, Like every room they walked into, they were like, oh crap, printer. Oh look, there's a printer. Hey, there's filament. Filament all over the house. And I hate to really think about it, but a lot of this filament is going to be collected up and moved somewhere, hopefully, fingers crossed, shortly. And at such time, I'm going to actually like count all of it and then sit in the corner in a fetal position, probably when I realize how much filament I actually have in the house, because it's just in piles and stocks everywhere. Yes, thanks, Shrimp Father, and happy Veterans Day to all of you that may be veterans in this chat that I may or may not be aware of your veteran status. The day was good. It was relaxing. Like I said, we had a couple of friends over, and we chilled out. We went over and checked some things out. Went to a local diner, had a nice lunch, and yeah, just relaxed. You not look at, yeah, just don't look at what. That's the thing is, I'm not looking at how much I spent, though that's probably why I'll be sitting at a quarter, but it may actually be good because I'll be able to put everything in one place and go, wow, now I know. Yes. Yes, I did see that too, Water. So Polymaker is launching refill spools. So what's this all to send them filament? Yeah, well, hey, you send me filament, I will put it to good use. I guarantee you that. But yeah, I will tell you that I posted a short and on a short on YouTube and all over the interwebs about a print fail. And it was sad. Um, while Waters and Clover and Evil Diesel were over here today, we had a power blip. And luckily, fingers crossed, knock on wood, the whole 9 yards, we haven't had another power blip and the resume feature worked. So great. What was that resume feature printing? Or what were we trying to print? Well, we are printing out a set of FDM Geo cases. So these printed fine, the standoffs for the crossover printed fine. The case, which is a 24-hour print, is what had failed to do the power off resume, right? This is EPAC's metallic red PET G. Okay. And yeah, it's 984 kilos, God. 984 grams, so just about an entire spool of filament is used for that case piece. Uh-oh, Pez Liz is on a 3-stream streak. That's awesome. Yeah, they print well, and in fact, it prints with 0 supports, and it prints standing up like this. So this is, all the contact area that you have that's holding up this big, huge print. And it is amazingly stable as it prints. And these printed out really, really well. And I don't know why I wasn't expecting these to be this big, but these are pretty substantial size here. Really looking forward to putting these together. They will be coming to a stream near us soon. We're going to have the FDM Geos, which are 5-inch woofers, and the 1-inch tweeters. And then we also have the FDM 8 S, which is the powered subwoofer. So we'll have a full speaker set here to play around with soon on the stream, and will be used extensively, put it that way. Yeah, no worries, Waters. Everybody knows now. It works very well on Prusa. I have not had a failed power off resume on a Prusa to date. Knock on wood. Right? This was on the Kitty Q2. And like I said, the first time I went ahead and tried to resume print, and something caught and it skipped a bunch of steps. And print was lost. And I know some people said, hey, figure out the height, just print the rest of it, glue it together. It's a speaker enclosure. I want a contiguous print. I don't want a chance having that separate after getting everything built. So I just went ahead and reprinted it. But yeah, let me go over to the bench side to see if we can get rid of the glare a little bit. But I mean, you can see, you know, the layer lines and stuff. But this is the, like I said, this is the metallic red from EPAC's Pet G. Got a nice good shine to it. And we're going to put a metallic gold trim ring around the speaker. And that's going to be, you know, the metallic gold's going to be our accent color for the speakers. And then we've got our tool heads that we've been working on. So we got our modular docks put together. We've got 2 of our tool heads pretty much done. We've got the orbiters installed and everything wired up except for the heater and thermistor. I still need to extend the wires on these 2. What I was finding out is the insulation on these will slide directly off the wire real easily. So kind of what you need to do is slide it up, trim it, and then slide it back down, because trying to strip it like a normal wire doesn't work. And unfortunately, to do that, the easiest way to do that is to, well, take the things apart, because with the way these wires are routed in there, you can't push the insulation back down over the wire because the wire is going to bend out. So I am going to have to take this apart to actually do the 2 orbiter-based tool heads. But on the other 2, we do have the heater wire extended and the thermistor wire extended. So we'll be able to go ahead and terminate these 2 fully, which is 2 and 3. We'll be able to terminate those fully tonight after we get the Galileos put together, and we've got all of the parts for the Galileos ready to go here. Let me just kind of get these out there. There we go. So those are all printed out and ready to go. And that's kind of where we're going to start tonight, is putting together our Galileos. Yes, it is definitely getting too cold to streak there, Pezliz. I don't know what your weather's like up there, Liz. I think you may have gotten some snow, but here it is 40 degrees Fahrenheit. So it kind of a bit chilly. Kind of a bit chilly. I'm going to bring the stool out, and let's see, what do we need? We need the Galileo boxes. We'll need the stealth burner, or the Nighthawk 36 Stealthchanger versions. out here as well. So we'll get that prepped and ready to go. And let's see. Pull out the things that we're going to need, which is going to be everything here. We'll just pull everything out. Pieces. And just like normal, we will build both of these side by side. So we'll get all the parts out, and as we go through, we will build them one after the other. Have our Galileo stickers that we can put somewhere on the printer. Canada is built different. There you go. See, I just realized we're going to have to grease some things. I should have wore my Coffee and Lube Stream shirt, Liz. Those over there, that can go there. We will have to do some heat press inserts, but let me jump over to our browser window where we have the instructions over here. Now, like I said, I reprinted all the parts. We're building the standalone version. Yeah, don't forget your gloves. I will glove up when we get to the lube. Standard boron stuff here. Let me see, they change any recommendations. ABS ASA 0.2, 0.4 forced, 4 top, 5 bottom, 40%. Grid, gyroid, honeycomb, triangle, or cubic. Yep, all pretty much standard. Hey, Bexy Bees, how are you doing tonight? Subscribe for a total of 19 months in a row. That is amazing, Miss Beans. Hey, 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 how's it going, whoa? So we're going to be we're going to be building our Galileo 2 extruders. These are going to be very, very comparable to our orbiter extruders that we have on the first 2 tool heads. So they're going to, same bolting, mounting pattern, and stuff like that. So we're good to go there. This is just going over all the parts that are there. And we're going to get started by putting in some heat set inserts. So let me get our insert tool up here. And get some power onto that. Uh-oh, what's going on? Bexy Bees with the 10 bits cheered. Thank you, Bexy, for the 10 bitties. I appreciate that. Hey, Waters. I logged into a site today to check and see if there was any progress, even though that office is closed today. And apparently some things had been updated. So I will be calling them tomorrow. Hey, Mr. Wizix, how's it going? Welcome in. Thank you for the 22 months of subscribing. Wow. Thanks, Mr. Wizix. Almost a full year. Excuse me, 2 full years. Wow. Words and math apparently are hard on stream. You're looking for an extruder to put on your Neptune 4 Max. Waters, do you have any idea? I'm thinking Neptune 4 Max. I'm not even sure what the tool head looks like on that. Physically, mentally, and emotionally tired. Yes. Can I respond with just yes? I agree. I had the gang over today. We were hanging out and chilling. Gave everybody a tour of the Dragon Den, and then I was like, all right, I got to get ready for stream, which means I need my afternoon nap. So you got to leave. Took a little bit of a nap, chatted with Westery, my sister from another mister, and yeah, it was time to get ready for the stream. All right, we're going to kind of do the same thing here. I'm just going to combine everything together. Hell is that noise? Uh-oh. Combos started. You have 1 minute left to join. I do not understand that. What are the combos? Evil Diesel did something. Oh, gotcha. It's moving stuff around. The 4 Max, 4 Plus have a volcano style nozzle. Okay, but what about the hot end itself? Or I'm sorry, not the hot end, the extruder. Combo level 1 achieved. Awesome. Yeah, apparently it was people cheering bits. So Evil Diesel cheered a couple of bits, and Bexy cheered some more bits. Who cheered bits? I don't know. I'm confused. I'm confused. Evil Diesel was over there cheering some bits and set off a combo alert for whatever reason. Okay. Diesel and a Bexy Beams. Awesome. All right, so we got some heat set inserts. I'm just going to go ahead and start putting these in. And then we'll combine the rest of our gubbins. So it looks like we need 1, 2, 3, and then one over here on the side. So 4 total. So we'll go ahead and slap these 4 in. You like QuarkXY more than Bedslinger? Yeah. Stealthchanger is, it's going to be interesting. I do have a tool changer already in the form of black box, but this is going to add another option. We've also got the IDEX in the form of the rat rig, but I do like the QuarkXY. I like the fact that whatever the size of the printer enclosure is, that's what you're dealing with. You're not having to deal with having to account for the need for space in front of or behind. Just makes life a little bit easier. And then there's just so many cool upgrades you can do. Like this, we're taking a Voron 2.4 and making it the Stealthchanger. Right, so you can start off with a 2.4 and then make it a Stealthchanger, and you're good to go. And we've got a hype train incoming. All righty. Here we go. We got a combo level 3 achieved. Hey, Zombie, how's it going? Thank you for subscribing for 22 months. Holy hat. That's like what? Almost 2 years. Sweet. Big Jano, thank you for the 100 biddies. I appreciate that. That is awesome. Thank you very much. Zombie, where'd I put it? We got a project coming in. In fact, there's parts of it showing up tomorrow. I don't know if it's the FDM Geo parts or the FDM 8S parts, but we got both a set of Geos planned and the subs planned. So this is what failed. This was the epic failure that we had. It failed about right in this area of the print. So about like that high. And about 14 hours of our printing time was lost when the resume failed. And I did not want to try and glue pieces together because there's no guarantee that a complete layer finished. So you would always have a weak spot in the print. Like, I haven't had a problem with my Prusas failing at all. Now, other things have failed, but not my Prusas on a power loss resume. You really need a tool changer for your Neptune 4 to have a tool changer because I'm not really looking for multiple material right now. Basically, I've created Trident out of it. Icarus. Just added one more Z-axis like a rat rig, changed the main board out with an Octopus 1.1 with 2209 drivers. And what was it you changed, Icarus? You're converting your Neptune 4 Max to a Core XY. Nice. Hey, thank you for the follow. We're just going to go with Alex. We're just going to go with Alex. How's it going? Alexi Lateroff beyond. Okay, yeah. We'll go with Alex or Alexi if you so choose. Build size is 420 by 420 by 580. Oh, that's going to be awesome, Icarus. Yeah, that's going to be a big boy build. That will be a big build. So yeah, we had people over today. Good day, just chilled out, relaxed, hung out. Yesterday, I was working down at Ecovate 3D. By that, I mean I was working. I just went down there and basically co-worked from their facility. And between meetings and after meetings, we worked on the Optimus P1. And I will say, we've got it homing. We've got good movement. We had to figure out some of the movement stuff. But she's up and moving. We're still playing around with amperages on the motors and debating whether or not we're going to take another step back and yank the X and Y axes apart. So we're getting, so on the Optimus, we're seeing some points where on long moves, it's going good. During standard travel moves, it's going good. But every once in a while, when you tell it to move like 10 millimeters, it skips a step. And we're not sure what's going on there. Now, this printer did sit in a garage for 4+ years. So what we're thinking about doing is getting all new belts and at least the idler pulleys, not the drive pulleys, but the actual idler pulleys, and replacing all of that. And at the same time, taking the rails off so that we can remove the carriages, soak the carriages in IPA and flush them out really well, and repack them. And the reason being is we got to looking when we first heard it do that, like, and not really move well. And it looked like there might have been some rust on the rails. We got well, I asked them to bring me some IPA, so they brought me some IPA, and it wiped off, which meant it wasn't rust. IPA will not remove rust. What IPA does remove very well is tar from smoking, vaping, stuff like that. So I have a feeling that while we know that the person that owned the machine didn't smoke, where they had it stored at, somebody there may have been a smoker. So, yeah. Sounds like a control loop problem. Well, and these are on TMC 2209s, and what we realized was after looking up the motors, taking pictures of the motors and looking up the specs on the motors are rated for 2 amp, and we had them configured for 0.8 like a standard Voron, and that would be the issue. So we upped them to 1.2, and they were happier. Yeah. So I think that might be all the heat set inserts we needed so far. It's not telling me anymore, so I'll go ahead and put this away. But yeah, we've got it moving, we've got it homing. I freaked Waters out big time. He did not know that he was running around doing some other stuff, working on a repair, I believe, for somebody, and he was not aware that I had already calibrated beacon. So I told it to home, and the bed's traveling at 20 millimeters a second on ball screws. So it's just like, and I mean, it comes up and just dead stops when the beacon triggers. And he was like, oh my God, scared the bejesus out of him. It was kind of funny, but not. But really, it was. Hey, Timor, how's it going? Oh, Bexy, I'm sorry. Hopefully some tea will help. I hope. Let me switch back over here. But yeah, the Optimus P1 Pro is moving. We're debating, because it sat so long, do we... It's hard because it's 15 millimeter belt, which means 15 millimeter idlers. And we're going to have to get some of that stuff on order. And then, yeah, it's, do we take the thing apart? I do have a video. We were pushing plastic. And as soon as it started to speed up to do accelerated moves, it skipped steps. So... Okay, so, well, you should be, well, yeah, I was going to say, if Icarus Links is using Icarus Links on Discord, then you should be able to just search for the name in Discord. But you're sure just resting up here with the best beans will help? Yeah. Well, and you've got your little snuggle buddy, right? Snuggle up with your snuggle buddy. But yeah, Evil Diesel was down there and everybody was down there. We got it moving, which was great. We're pushing plastic, so that's good. The other thing is I did run input shaper on it, and this is why we're thinking we probably need to go and get new belts and stuff, because input shaper had us max acceleration under 1,000 millimeters squared per second. And I'm like, yeah, something's wrong here. So we're going to have to do some more work on trying to get some things set up. And it may just be we have to get off the TMC 2209s and go to like 5160s on the X and Y and push more amps at it. I'll have to look at it, honestly, down under Maker. The X is a single X motor. The Y is dual motors sharing the same TMC 2209 driver. The one axis was like, keep it under 1,000 millimeters squared per second. The other was under 900 millimeters squared per second. And at least one of the belts is a little loose. And that's where we're saying this thing sat for 4 years in a garage and was filthy. So we might just be removing, replacing the belts and the idlers. Yeah, splitting the two drivers might be enough for Y. The issue that we have there is the current wiring is both Ys are in parallel on the same driver. And we've already yeeted 3 14 wire aviation cables out of the loom just by switching the tool head over to CAN bus and the beacon probe. And once again, cleaning the carriages. So the carriages here are, wow, okay. Let me move that down some so I can stay seated here. And all right. The carriages that we have here are all MGN 16 high wind rails. And while the X linear rail can come off fairly easily. I mean, we got to disassemble some stuff, but we can disassemble it. And we can get the X rails off fairly easily. The Y rails, I don't think we have direct vertical access to the screws, which means we're using an Allen key, which is going to suck. I've got to see. We may be able to take the entire top gantry piece out. I've got to look at the way it assembles a little bit more, but I'm a little fearful of tearing it apart to that extent, but we might have to, because once again, with the amount of, and I'm assuming it's tar that we cleaned off the ends of the rails and it wiped off clean with IPA, there may be some of that gunk in the in the carriages. And the only way we're going to get that out is to pull the carriages and, flush them with IPA and then repack them. Yes, and do brake cleaner, then dry, then re-grease. Yeah, but you can't do that on the rail, can you? You still got to take it off the rail. And that's the thing is, how do I get it so I can get access to pull the carriages off the rail? Yeah, those rails we're discussing with what came off the, and I keep forgetting, yeah, multi-headed Voron was there. So yeah, we're gonna have to figure something out. And there's a part of me that's just like, oh, I really don't want to take those rails apart, but we may just have to. Thank you, Mrs. Dragon. We got a dunk and run. We got a dunk and run. Yeah, so everybody's here. Yeah, if they're a real high wind, you don't need to take them off. Yeah, they do have the ports. It was just more of if you're spraying brake cleaner or IPA or anything else in through the grease ports, that stuff's got to go somewhere. Where is the old grease and stuff going? I guess that's my point, is how is that stuff getting out? Because you've got the wipers on the edge. Just spraying the brake cleaner in there to break all that crap out, there's no way of really getting it out of there to clean them well enough and then re-greasing them. So there's a grease zerk on one side and the other side has a screw. I guess we can take that screw off and see if we can spray all the way through. Like I said, I have not worked with rails of this caliber. That's kind of where I'm going there. So anything that you can tell me that may help us keep from taking everything apart, yeah, that would be great. I will. Okay, we'll take a look at that. Evil Diesel or Waters, if one of you could take a note down of that, and we'll go and look at the. We'll look because I'm sure there's some maintenance manuals on high wind rails. We'll go and look and see if there's anything that we can do to get that stuff prepped and ready. For now, we'll switch back over here. Bexy, can we just put the whole thing in the dish? Oh, that would be great. It's actually too big to fit in the dishwasher. It's 600 mil. Well, yeah, it's over 600 mil because the travel's about 600 mil. We did lose some travel, by the way, because of the new tool head. We did lose some travel, but that's fine. We're basically 550 by 520. Oh yeah, I'm with you. Like I said, I have not used this caliber of rail. Normally on an MGN 7, 9, or 12, you normally don't get a grease zerk, but on a 16, you do. While I've got 16s on the mills, I haven't had to really go in and repack them once they're on the machine. So, but that will happen here in the future. Okay, planetary gears. Intergalactic planetaries. Start by inserting the bearings for each of the 3 planetary gears. The bearings should press fit with little effort. And it's okay if it's loose enough to fall back out. We will have, they will be going on to the ends of these, so they will be captive. Yeah, you can get them on 12s, but they're not, I'll say, a guarantee on that size of printer. Normally they'll have a port on them and they're blocked. It all depends on the manufacturer and how nice they are to us. All right, so we're grabbing gears. I don't know why I've got 2 sets of the small bearings and 1 set of the larger bearings. But we'll go with it. Okay, so smaller bearings get pressed into the gears. Shall I bring you in a little bit closer? Let's bring you in a little bit closer. Ooh. There we go. Let's bring you in a little bit closer. Okay. So what we're going to be doing is getting 3 of our bearings and putting them inside of the plastic gears here, which are the MJF planetary gears, being 3D printed nylon gears. And these should just press fit down into the gears, provided everything is nice. So that's what we're looking to do, is just press fit the bearing down into the gear. I'll have to do this for all 6, 3 per extruder. Yeah, unfortunately, a lot of times when you're getting the Chinesium ones, the grease supports are not viable ports on them. I do know that my mills, though, they do have the higher quality rails and they do have grease zerk fittings on them. It's just I haven't had the need to fill them up that direction yet. Did you see the Big Tree Tech Vivid line got reduced from AMS and AMS with dryer to only being AMS with dryer, and they got it down to the $299 price point? Yes, correct. And I will be going to, me and Waters are leaving Sunday for Formnext in Frankfurt, Germany. And I plan on trying to see Big Tree Tech, Elegoo, Anycubic, PD Tech, Prusa, E3D, Luke's lab. He'll be in the same building as us. We'll be over in building 11, first floor, and which is 0 in Europe. And then Luke's lab is upstairs on the first floor, or the second floor. I should say we're on ground level, which is 0, and then Luke's lab is on the first floor, which is the first floor off the ground. I do have Centauri carbons. I've got 4 of them behind me. Talked to Luke about joining the beta team. I can do that. Yes. Luke is in, was it Singing Surfer? Tall Luke? Okay, now we're going to take our 3 planetary gears and put them on the dial here. Let me check something real fast. Okay, what I was doing was just checking to see if I needed to put any grease on these yet. So what we're going to do is we're going to take those 3 gears and put them on these posts here on the planetary drive. And we're doing it where the bearing is facing inwards here. And let me see if I can't get you close up here. When they milled these, there is a slight step there right by that post that acts as a washer. So that's where the contact is with the inner bearing race, which is the inner ring that we see here. And then the outer bearing race is the outside shell. So we're just going to set these on there. These do not mesh with each other. There's a little bit of a gap, right? What's going to mesh is all 3 of these will mesh with the drive gear on the motor at the same time. So there's one. And so once again, you should see all black at the back ends of these. If you're seeing the bearing itself, like you put it on that way, that is not correct. Flip it back over so you're seeing the whole black. Yes, the South African Luke from Big Tree Tech. That is correct. He goes by Singing Surfer, I think, on X. The GT gearbox is made from MGF nylon and as such is subject to printed part tolerance just like any other printed part. Unfortunately, this means the same gearbox will be, or that some gearboxes will be tighter than others, blah, blah, blah. The best way to ensure a smooth running gearbox is to manually run in the gears using a drill. We will be doing that. Start by wrapping the carrier shaft with a strip of paper to protect it, then loosely chuck it into your drill. Spin the carrier back and forth at high speed in short bursts while you hold the ring gear in place. Do this for about 30 seconds total before blowing out any residue of the MGF dust and proceeding with assembly. So here we go. We're going to need our drill. We'll need some paper, or in our case, I'm going to use some paper towel. To wrap the ends of our things with. Once again, this is just to protect the metal while we chuck it into the grill, because this is an aluminum and your grill chuck is going to be steel. It will mar the aluminum if you're not careful. Your leg's acting up. Sounds good. All right, that's in there. We're going to take the gearbox and slip it on. And then while holding the gearbox, we're going to pulse this. Slide this off. Blow out our gearbox there. And now this gearbox is good for this set of gears. So we'll now be kind of matching these up. Once again, short pulses. Okay. All right, so these have now gone through the initial, we'll call it break-in. now, put a ring on it, and don't forget the lube. After running in the gearbox manually above, double check for and remove any residual MJF dust that may be in the gearbox before moving on to lubing the gearbox assembly. I am going to blow these parts off. And yes, I am doing it by mouth. Okay. And we're going to put a pea-sized blob of grease on the bottom flat surface of the ring gear housing, then insert the carrier with planets into the ring gear housing, rotating while installing and giving the carrier 10 to 20 full rotations to allow the grease to move around and fill all the nooks in the gear face. You can use the drill for this step as well, but do take care not to sling grease everywhere. We're not going to use the drill. I don't need grease in my coffee. And yes, Timor, it is currently 37 degrees here. So I am ignoring it was 104 in your backyard today. Though I do get it. I was stationed in Tucson, Arizona, and that was a lot of fun. But yeah, I will definitely reach out to Luke to see about joining the beta team. Because I would love to join that beta team. Okay, we probably have enough grease here to do both of them without digging into the second thing of grease. So that is going to be my plan. Here's the tear edge. It says a pea size. I don't know what they mean by a pea size. A pea can be lots of different sizes. But we're going to squirt some in there, and I'm going to try and get it not just on the flat, but near the gears, the teeth. Just a dollop. One there, one here. Those are some big, good peas. It's a good harvest this year. And now we're going to put our gears in there. I'm going to kind of put it where the gap is next to it. And I'm just going to rotate this around. And most of that grease came out. So we'll, whoops, good job, Luke. Most of that grease came out. So I'm just going to take that grease, move it up there onto the gears. Put it back in, and we'll just keep spinning it. Once again, making sure it gets into all the nooks and crannies. And don't be afraid to pull these apart and do maintenance on them. Meaning somebody just posted recently about their neck extruder gears, where they took their neck extruder apart and cleaned out the old grease, cleaned everything off, and re-greased it. Would not be a bad idea to do with your Galileos, your orbiters, or just about any of your other extruders. I've recently had to do it with my one of my bamboos, where it was having some issues, and I had to take the extruder apart. And when I did, I wound up having to clean all the gears. and that's just from the dust. Because these gears have teeth, and those teeth that bite into your filament, you know, they do carve out a little bit of stuff, which means that that stuff that gets carved out by the teeth in your drive gears has to go somewhere. And it just so happens that it gets caught in this grease and starts gumming things up. What I'm doing is just getting some of the excess grease off the top edge of the mating surface. Right. Now, ECAS fittings. Love ECAS fittings. Now, there's two different types of printed parts that you can do. One will take an ECAS fitting. The other one will not. The other one just takes a press fit collet. We did the versions with the ECAS. I kind of like them a little bit better. They give you a better connection. Every time I do one of the standard collet ones, it never comes out well. But in your ECAS fitting, we're going to need the blue part and the metal part, because these are the metal ECAS fittings. You're going to take the little black ring off. So you want to just try and grab the rubber ring and pick it off, and you should be left with that black plastic piece there. So you need to keep that black plastic piece, but the rubber ring can come off. And I've got a good collection of them somewhere around here, so I'll just set them to the side and maybe add those in. You've got to get these two parts together. Normally, squish it down on a hard surface will get it there, but instead of damaging your fingers, you can always use a pair of flat jaw Nippics if you got them. I mean, if you got them, might as well use them. Just be sure to slow, even pressure. Just like that. That's in. And you can leave the rubber piece on when you do this, so you don't stand a chance of marring or compressing the black plastic piece at the bottom of the ECAS fitting. But I haven't had any problems. So, yep, those are all good. And now these are going to go into this end piece. Now, it could be easy or it could not be easy. It depends on your print tolerance. Tinkercad has had a server cough and a bunch of your stuff, and some of my students probably, oh no, that's not good. All right, they do provide, this is an LDO kit, so they provide a 2mm drill. Before you put your ECAS in, now is a good time to check and make sure that you've got good clearance down through your filament path. And you see me doing this by hand. I am not using a drill. I don't want to use a drill. I'm going to do it by hand. Normally where you can get a little bit of ickiness is right there at the out or end is where you'll get a little bit of excess. And so just using your drill to go through both directions will help to clean that out and keep your filament path nice and straight so that you're not going to have an issue with your filament. And it's always nice they give you these. 2mm bits are hard to come by. Now we need to get our ECAS fittings in the top here. And like I said, they can either be very hard or they go in very easy. You do want to make sure that they're fully seated all the way around. And that they're nice and flush to the printed part all the way around. And then it's also good to make sure that your little pneumatic clipper works. Do that to both of these. And you definitely want a hard surface. If you do it on a surface that is wood, congratulations, you will dent your wood by the time you get these in. All right, so both of the ECAS fittings are in. The planets are aligning. The rear plate should slot into a specific space on the gearbox, and there's 2 aligning tabs to help with that. So it's talking about installing the rear ring on the gearbox, yet it hasn't told us to install the gearbox around or onto the motor yet. Which, okay, so we have a motor, we have a gearbox, and the large shaft is coming away from the gearbox. So this should sit down on our motor. You may have to twist it around to find the right spot where all the teeth line up. And then make sure that your wings line up and that things will turn. If things don't turn, take it back off and try it again. Be a bit fiddly. So, all right, why are you Why are you being cantankerous? There we go. All right, one on. I get the other one on. There we go. Now we've got our locking rings, and once again, the locking rings kind of have the little depressions built into them. And that's going to line up with these locking features that are on the edge here. So you've got these little locking lips here, or edges. And that's what's going to line up with these locking edges here. This is going to line up and go right over the top of it. And I'm just going to look at, okay, the wire is coming up one way, and there's a little divot here. I think that goes towards the bottom side. But we shall see. Now we're going to want to put on the front face, or the, what do they call this? I don't know. We're going to install this once again with our stepper motor drivers in the top, we'll say the top left position. And we're going to use our M3 by 20 screws, 30s, 8s, 6s, skim washers, 50s, 20s. And these go through all of the parts that we have there and into the motor ears themselves. So do you have any recourse with Tinkercad? Like, are they able to recover your stuff, or are they basically saying you're just SOL? And I'm just snugging these down. I'm not really ugga-duggaing them at this stage. Same thing here. We're going to put this in place. And you saw me kind of turning the shaft. I'm going to wait until I get this one screwed down. It'll make it easier to turn the shaft. Without things turning on me. SOL at this point. Oh man, that's not cool. Okay, now what I'm trying to do is take the flat and line it up with this opening over here, because I know from looking at a future step that I'm going to have to do that. And that gear is now, feels like it's bound, so I'm just going to un-ugga-dugga that a bit. There we go. Now I'm going to get the flat lined up with that opening. Same thing here. My flat's lined up, but I want to make sure that my motors are turning. And if you ugga-dugga these down too much, the motors will not turn anymore, which is not what we want. BBIAF going to speak to IT and see if they have any cache content. Oh, I hope so. Because that's going to suck if you don't and you've lost a lot. Okay, so the planetary gearbox, we're going to ensure the flat face of the carrier shaft is facing towards the opening. That's what we just did on these, is made sure that that shaft is facing the opening. Install the custom 16mm drive gear into the carrier shaft, sandwiching it between two MR148 bearings. And ensure that the filament path is facing inward. Leave the grub screw loose for the next step. Gear spin, grub screws, pin. Very important step. So we're going to use the SMR1482RS. Yeah, that stinks, Down Under Maker. But yeah, definitely thank you for the information on the bearing blocks. Hopefully we can get those flushed out without having an issue. So these bearings can go all the way down. There we go. We're going to take the extruder gear. Okay. One extruder gear, two extruder gear. Be careful because the grub screw is not in it from the get-go. But the grub screw does come with Loctite already. So thank you once again to our LDO folks for making sure that our build experience is as easy as possible. I'm going to go ahead and get this started. And in fact, there's two grub screws in each package and you only need one. And I'm going to put this in so I can see the grub screw in the hole, but it's not in. I can see the grub screw when I'm looking through the hole, but it's not engaging yet. And your drive teeth, the line of drive teeth, are towards the bearing that we've put in. So it would be in line with our filament path. And just make sure that your set screw is in line with the opening as well. I'm just going to push down to make sure everything is seated down into position. Yeah, the pre-treated set screws are definitely the best. All right, so those are just pressed down in there. We're going to take the other bearing and put on the front or on the top. Push everything down on there. To properly align the drive gear and the carrier shaft, press firmly down on the carrier shaft until it won't move any further. Should be slight, it should, there should be roughly 1 to 2 millimeters of total travel in the carrier shaft. So moving the shaft up and down, you should have 1 to 2 millimeters of travel. With the carrier shaft fully seated, press the drive gear flat against the screw and then tighten the grub screw. Now, all right, I'm going to say we have a slight issue there because this bearing is not pressed down in there fully. And therefore, tightening up this grub screw, it's not even going to be anywhere near in line. So I've got to do some more pushing and pulling here. Press firmly down on the carrier shaft. There we go. I just felt something move again. Then we're going to push down on this stuff, which just moved. And now you'll see that our teeth are lined up in an appropriate fashion. Our gear kind of shifted a little bit to the side, but we'll get that there. We'll tighten this grub screw down once again against the flat of the shaft. And that's where we're going to look like, where our teeth should be lined up with our filament path. Which it is. It's just looks a little funky. Gears are still moving, so that's good. We'll do it again over on this side. Once again, we need to push down with a decent amount of force on the shaft. We'll push everything down, and then on our bearing stack here, we're going to push everything down in there. Ugga dugga that set screw. Now we do have 2 spare set screws that are Loctited, so we will set those off to the side so that we can store those with any of the extras. Make sure this is still moving freely, which it is. That's good. With the carrier shaft fully seated, press the drive gear flat against the printed surface and tighten the grub screw. Use a small drop of thread locker to ensure the grub screw doesn't come loose over time. We are there. Hey, Maker Viking, how's it going? We're building our Galileo 2 standalone extruders. Now we need to put our front face on here. This is the front shaft support piece. And this will go on, and it's going to slot over that bearing and push into that bearing. And it does have a key feature down here that'll lock in with the slot right there. You just line it up and push it down over that bearing. And then we're going to put in some M3x8 socket head screws. I hope everything's going well with you tonight, Maker Viking. So we're just chilling out and doing our extruder builds. We'll be able to get those installed on our other two tool heads and use the right size driver, and I guarantee you the screw will actually drive in. Hey, LTX Designs, how's it going? Welcome in. Hope you're doing well tonight. We're in the middle of an ad break, so hopefully you can hear me. If not, I apologize. Channel needs to make money here and there. Now we're going to, we're going to do our tension. So we're going to use a bearing pin and another one of our bearings. So we have two M5x16 shafts. We only need one, which is nice, which means once again we're getting spares. We'll need that. We'll need that arm, but these two should be spares. We'll throw our locking nuts in there. You know what? I've got shims. Why do I have shims and I never saw anything about putting a shim in anywhere? Yep. I guess it depends on which extruder you're setting up. Sorry for this, for the desk scroll there. Ads just finished. Good. Good. I'm glad you're doing well. So make sure the bearing spins freely. So we need the another bearing. This is a MR115 bearing. I have plenty of extra bearings. Once again, the Galileo kits come so that you can build it one of what, 3 ways: the extruder, which is basically a GW2, or the standalone, or possibly even as a Z kit. I don't know, but we're gonna have plenty of extra bearings and other accoutrements. So these basically just fall down in there. We'll need to make sure that the hole's lined up. We'll press in our bearing, and it's going to go all the way through. And the other side, it's got a raised edge, so we'll be able to take this all the way through on a flat surface so that this side is nice and flush. Make sure your bearing still rolls freely. And if you ever need to get this out, you can poke something through this end and push that rod back out, or the pin back out, and be able to, I don't know, do that little thing called maintenance on these things. And just like that. So in this case, we've got one large tooth pulley going up against a bearing. We're not doing dual drive gears or dual tooth gears against it. And these are just going to sit in there like that. We'll put an M3x20 through the front face there. And we're not going to tighten it all the way. This is a pivot joint, not a, it's a pivot joint, not a locking joint. So we just need a little bit of tension on it and we'll be fine. Once again, these are M3 by 20s. Hey, Kenneth, how's it going? Hope you're doing well today. Got some good movement there. So once again, the way I normally do this, one finger sitting on the top. Pull you guys back out a little bit. One finger sitting on the top, that is just to keep it from falling over, and fingertips. There we go. And I will tighten this down until I feel the first hint of resistance, and then I'm done. And that should still give me plenty of movement, right? There's no need to really ug and dug it and then have to back it off. Just go and light pressure, just using your fingertips. And as soon as you feel the tension change, you're done. Now you have the option. You can leave it bare like this, or you can put a knob on it. There's two types of knobs. I did the one that has the printed slit in it because they go on and they stay pretty tight. Every time I do the one without the printed slit on it, it feels like I've got to hammer the darn thing on, and then trying to get it off is always a pain. But now you have a knob on there. One, it adds to the little accent, and two, you can now turn it using that knob. And it can give you a movement indicator. Is the knob turning to the right or turning to the left? In this case, if you're trying to extrude and your knob's turning to the left, you're going the wrong direction. Okay, so we've got two extruders built. Better go actually teach for a few. Okay, sounds good, Down Undermaker. So someone say Bowden. So there is an optional build for Bowden. We did not do that. We are going to add our tensioning arm as well. This should just go through and start in there. And I'm going to do the same thing I normally do, which is, once again, finger tight, just using your fingertips. Boom, it just changed tensioning, so it's tight. And now I'm going to take it and undo it one revolution. That's my starting tension. You don't want to sit here like really crank down on it because chances are all you're doing is going to strip your heat set out. Just making sure, because that felt like it wasn't lining up with the heat set, right? That is not lining up right. This feels like I've got some fouled threads on this. Or at least something is not right on this one. like that right there is as far as it's turning in. So there is something with that heat set insert, or the threads on this screw are borked. I just got my nail in the thread and I'm threading through it. Okay, and I didn't feel anything wrong with the threads on the screw, which means it's got to be something with the, potentially with the threads on this. Let me get my expert eyeballs out. Okay, and I'm not sure if I'm going to be able to get this on the camera here, but you guys and gals see the bork thread there? So the thread on this heat set is borked. I don't know if I can clean it up with the tap, or if we're going to have to try and extract the heat set. Fingers crossed that we can get this thread cleaned up. I think we're in luck. We got that squared away. All right, and once again, using just fingertips, we're going until we feel the change in tension, right? Tension's there. And I'm going to grab it with the extruder facing up, and I'm going to flip the extruder through one full turn. That is my starting tension on all of my extruders. I am kind of glad that that worked on cleaning the threads up there. So our extruder's built, and that's where we're at. So the next thing that we get to do is we'll close this out and we'll go back to our Anthead guide. Really don't think we really need to go through the Anthead guide, but I'm going to desk scroll down to the bottom. Our Anthead tool heads are built. All right, fully built, fully assembled. We've got our the white wires here, the extended white wires. This is our thermistor. The extended wires here that are black are the hot end wires. So those were extended out. Fans were attached. Now we're going to install the extruder. And we need to cut our PTFE to the right size. So what we need to do is depth mic this again. So we'll take our calipers. Take our calipers. We really don't even need the zero. All we're going to do is put this edge out. And we're going to set this up. Push it all the way down to where it hits the hole at the bottom. Slide that down so it's nice. And we're at 6.02 millimeters, but I'm going to lock this down. And that is the amount of distance I need to add to whatever I come up with here, which I believe it feels like it's the same exact amount that we did for our other extruders. So I've got some 4x2 here. I can use this, or I can grab the tubes out from in there. We'll take this, we'll push it all the way down. We'll see how much of a reveal we have. Dude. See that? That is freaking perfect. So, I can get this come back out. That's the exact length. I need one more tube like this. We're going to chamfer the top piece that's going to be facing into our extruders, and then we'll be good. And do I have any? I do not. But that's okay. We got PTFE tubes. I'm going to pop one of these ends out, and I'm going to mark the distance that I need. And then we're going to use our handy dandy PTFE cutting guide here. This is printed in PLA. It probably would be better off to print in PETG. And you probably should not keep it tight on your bench like I did, because now it's, I have to like pry it open to get my PTFE tube into it. But what we're going to do is we're going to put our PTFE tube into the slot and push it in until that line that I drew lines up with the bottom of the cutter piece. And of course, I am going to drop every darn thing on the ground, because apparently that's what I'm known for on my streams. Okay. And we're lined up. And I'm going to be able to take a sharp blade, and because that is a flat edge, I'm going to take this sharp blade across that flat edge and cut this. So just like that, blade right up against the flat edge there. And I normally take it and I rock it across. And we got a nice flat edge. Now all we need to do is push this through and out. Dropping it on the ground in the process. And we've got two tubes that should be the same distance. Yeah. One is actually a tiny bit longer, so put that back in. And we'll take just a shaving off, like so. There we go. Two fully identical lengths. Let me grab my self-defense poker, aka the Capricorn Tubes PTFE tube chamfer tool. Always need that. We'll chamfer the end. You just put that in there, rotate it a few 3 times. Doesn't need to be a major chamfer. We're just trying to make it so that it has an easier path for the filament to enter through. Take our blade, put that away. We'll take our PTFE tube. Once again, the side that we chamfered should be facing up. Make sure it's fully inserted all the way in there. Take our extruder, our wires. We're going to have to kind of spread them out some. Trying to think how we did it. This is great. So these go this way. These will go that way. These go on either side. So I'm making an X. My heater and thermistor are coming on the right. They need to come over here to the left. My fans and lights need to come over to the right behind this motor. So we're going to kind of crisscross them. We'll stick our extruder on there. Oof to me. Okay. Okay. So what I got here is my holes are lining up, but the printed parts are not a little bit there. And I'm going to be squishing. This side I'm good. This side I'm squishing the wires that are coming out. So these two wires here, the hot end, excuse me, the fan and the RGB lights are going to get squished by that extruder mount. So that That side clears. It's the left side that has, this left side here has more meat over here, and this is the area that's going to be where that other set of wires is popping out. It is going to give us an issue because of that. And these wires really can't be routed the opposite side, I don't think. Can they? Well, we'll take this apart and we'll see what we can see. Just put a couple of things out of the way there. Put that there. Get a couple of yeah, we'll take the tool head apart here, and then we'll see where we're at. Put some things away, make us some room so we don't make a mess, at least more of a mess. Do 3x8s from the back. Hey man, size slack, how's it going? Yeah. So the issue we're having here is just the choices of things, and I don't know if it was I should have picked a different style fan, or if there was something else I should have picked because we're doing Galileos on 2 of these, though I was pretty sure that the Galileo you have mounting for either an orbiter or a Sherpa Mini as far as the whole mounting pattern. So right now it's whether or not I can run the other wires up this same channel or just some other way to get them out and around to this side. Yeah, doing good. Had a good day today. Like I said, it was Veterans Day, so didn't have to do a bunch and was able to basically relax. We had Evil Diesel and we had Evil Diesel, Waters, and Clover stop by from Ecovate 3D, and they hung out over here at the Dragon Den some and published Q nozzle camera mount for the P2S. Nice. Yeah, P2S, that would be nice. If you got a P2S, I'm assuming that you're not in the United States, because to my knowledge, we still can't get our hands on those. So we've got one captive screw back here that we've got to undo. And then our front shroud itself comes off. So this fan wire, I can definitely loop it around behind the heatsink. There's plenty of room to do that and loop it around and even bring it up around the side here. The LEDs, I mean, that is the way the channel goes, is it routes it out that left side. There is no opportunity to bring it out brings it out the left side of the tool head. There's no opportunity to bring it around the right side. And we bring it, we can bring it down and under. How much slack do we have on that? Because we do cross it over and bring it over. maybe. There is a possibility. We're going to do some wonky wire here. Basically, we're going to do it down and over. Yeah, that's going to be a fun one to do. Basically, what I'm going to try and do is rather than bring this wire up here, there should be gap space right here where I can bring this over and up with this one, or straight over and out the side. Now this piece comes up on that right, and I'm going to have to figure out how to make it come out the left. And I'm basically going to have to bring it down and kind of around that little slot gap there as well. Won't be able to come up, but will I be able to get it behind in that little slot? We'll see. I think so. The problem is how do I get this mounted and then get that down and around through it? That's going to be the moving the fan around. That's easier. That's the easiest one. The other one is going to be what's hard. This here go through. I'm just trying to think my way around this problem of how do we get the light down through the side. Because there's not enough room to get the connector down there. And once again, if we bring it this way, that locks in, that locks in. That is the only place that is going to go. Unless I go down, then I can go around the back. I can't go down getting it through this gap, I don't think. I loosen this. pop that out. Can't rotate that too much. I get enough slack to put those wires going down in that channel. And now to see if I can get things back in there. Okay. So super sketch. That's there, that's there. This wire can come around like that. This comes over here. So in essence, we've got these wires coming around the back side. There's still plenty of room there. Those wires go there. That's tightened up. This goes here. As long as I can get these kind of out like that, we should still have enough room. Now, there's a lot of the word if in that statement. If we do that, we're now short on the LED wire. Why am I bringing this all the way around to the right? What if I go to the left with that LED instead of coming out to the... Leave that LED wire over here on that side. We're doing some problem solving here. Dropping things. Bearded Printer rating with a party of 21. Hello, Bearded Printer. Welcome on in. Give me 1 second here and we will come over here to the main view. Welcome in, Bearded Printer, and thank you for rating in with your group of 21. Hey, Oz 1287, welcome in. So let me do my little spiel. My name is Digital Dragon. Welcome on into the Dragon Den. I am a 3D printing variety streamer here on Twitch. And what that means is I do everything from machine unboxings like our X1 carbons over here and the Centauri carbons down below to full up 3D printer builds like you see over here on the left with our Voron 2.4 and Trident. I also take part in our beta test for like Thetis and the Box Turtle and various other items that I can get my hands on and get into the beta test programs on. So what we're working on right now is we're working on our Stealthchanger tool heads. This is an Anthead style tool head. And we're having to do some on the fly troubleshooting. So we've got two of our tool heads are using Orbiter 2.0 extruders. And I'm finding that the hot end that I chose, which is the Thetis Conch Plus hot end, which is this little bad boy. Here, let me go over here to our side view. So this is the Thetis Conch hot end. It looks exactly like the bamboo because, well, that's what it is a drop-in replacement for the bamboo. We're having to extend our wires here so that they work in the tool head board or the tool head combination that we're building with. And like I said, we've got two of our tool heads built up here with the Orbiter 2.5 extruder. Everything's nice and neat, nice little compact form factor. Everything's wired up except for our hot end and the thermistor. I've got to extend these. Unfortunately, I have to take them apart to solder the wires to extend them. But everything's looking nice. And when LDO sent me these kits, it came with two. Man, one of those did not stick, so we'll have to reglue that. It came with, or I got two Orbiter 2.5 extruders and two Galileo standalone extruder kits. So we put the Galileos on. What we're finding is this side has the shorter cutout leg on it, and the wires can extend out no problem. The other side does not have that feature, so any wires exiting the left are in the way, basically. So what we're trying to do is get our tool head put back together and make sure that we can exit our wires out and see what we may need to extend to enable all the wires to connect in and wire up. And so far, I'm liking the Antheads. I built an Anthead extruder for Zura, who is Blue Chocobro on here. I built an Anthead for his Micron and really liked that tool head. So I wanted to do the Antheads, and I really liked the Fadus Conch setup. So I went ahead and did a Fadus Conch setup. And now we're just installing our extruders on here. Everything should line up. And I want to say this uses M3 by 20s. And I'm seeing a slight issue. So as I put this down so it seats all the way, this front edge is getting pushed back because once again, it's not lining up with the front edge here. So it's kind of rotating this extruder around slightly. And it could literally just be the fact that these are for orbiters and not a Galileo. I can see if there's a different fan shroud and just reprint the left side fan shrouds. Let me see real fast if there is an option. Anthead, do I name it? Printers for ants, Anthead, STLs. Yeah, no, the ducks are the same. But the Galileo here is the ones that I printed out that actually have the ability for a tool head sensor. And let me just see what this whole package looks like. Just put this front plate on there. Yeah, so this front plate would sit on there just fine. The standalone front plate does not. This edge here is just too far into the way. So it's this slant here. There's an angle coming towards the center as well as an angle there. So it's this angle, as you tighten it down, it's going to want to twist. Interesting. Printer, Pez Liz. It is a Nighthawk. It does use the Nighthawk Stealthchanger board. We are trying to get these extruders on there, and I wanted to use the Galileos because LDO Motors sent me the Galileo motors. And I really, really, really want to use these. If I use the standard Anthead style extruders here, this I think should work. The problem is it requires, I'm going to have to put at least a dummy sensor in here, if not wire up a filament sensor, because if I don't, it's not going to have a properly constrained filament path. Yeah. The other option is to go and order 2 more Orbiter 2.5s, because I don't think I have them on hand, and we'll just go through and make everything Orbiters, and then life kind of gets easy because then they're all 4 the same top to bottom. Thank you for the follow, Pixie Kiddle. Oh, Pixie Kitty. Thank you. Yeah, so I'm kind of... Well, I'm kind of there. That's kind of where I'm at right now. I keep wanting to try and get these tool heads done, and then we keep running into little things that cause us issues. And I will tell you right now, I am not above sanding that left side duct just enough so that the Galileo 2 sits on it. At the same time, since it's only the left side duct, I'm going to go ahead and do some looking and see if there's like a new left side duct somewhere that I haven't found, specifically for the Galileo standalone extruder on the Antheads. Because I'm sure it's there, and then all I have to do is reprint this one duct, pop this out. Yeah, we've got, you know, a magnet in it and a cup and a heat set, but that's easy. I could do that. And that would be the only thing that we would need to change is that one part. Pull the fan out and redo, you know, reassemble. And yeah, that's exactly, that's the thing down under Maker, is it's that little niggly issue that always seems to get in the way. And what we're trying to do is get as many assemblies done ahead of time as we can. Now, my original plan after talking with everybody was we were going to build the Galileo 2 ZXLs. Okay, so that's the geared Galileo 2 Z motors with the XLs, meaning rather than using the round NEMA 14 motors, it uses a standard NEMA 17 motor. I have been cautioned against that by Steve Builds and others from the Draft Shift Design, who's the designer of the Stealthchanger, because it has a slower Z movement. And because we're building a Stealthchanger on the 2.4, all of the modular docks will be up at the top. So all of our tool heads will be mounted up here, which means it's got to raise up, dock, pull off, and go back down every single time it does a tool change. The problem with that is if your Z is slower, then you have more chance for oozing in the print volume while you're doing those tool changes, because it's going to take a little bit longer. And I know people have got their tool changes down to like 5 seconds or less now. And so you do that so you don't have the oozingness. If we were doing a tool changer on, say, the Trident over here, the gantry itself is fixed. It's the bed that moves up and down. So you don't have to do a Z move as well as the XY move. You can just do a rapid XY, drop, wrap it over, come in slowly, drop the tool head, go over, pick up the next tool head, rapid back, do the purge tower to prime the nozzle, and then go back over and do the print. And it winds up being a lot easier and nicer. So that's kind of where we're at. Let me bring my keyboard over here real fast, and we'll do a little look-see on the interwebs and see. We got a Galileo 2 standalone extruder Anthead. See what we can come up with. Jared CO1, haven't seen that one yet. Galileo 2 extruder, standalone, Z, images, manuals, user mods. User mods. Umbilical for Z chain. Nope. 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 Don't see anything there that would fit the bill. Yeah. And there was nothing here. Orbiter 2 front plate mount. Rear plate G2. Tension arm. Shooter knob. Main body ECAS orbiter mount. See, that's the thing that gets me, is it's the orbiter mount. So why is that angle different? You know? Because this version would be not using an ECAS with a straight collet. And it's not really that piece, it's the front cover. So it's this plate here that we're having issues with. And it would be this side over here needing to be carved out some. And like I said, I am not above taking a grinder to this and grinding it down some. I really wish I could find a fixed body for it. If anybody knows or wants to use their Google Foo, that would be great. It's one of two things. Either I clip the front edge of the, you know, that little front edge tab of the left duct and reprint it, or I just take a grinding wheel or a sanding disc to the bottom of this and make an angle on this front edge. Jared CO1, which is the Anthead. I have a feeling if I look at Galileo stuff in printables, it's going to be, yeah, either the CW2 swap out or the wristwatch. Which the wristwatch is basically what the Anthead is anyhow, is the wristwatch style. Anthead toolhead, WWG2 flow knob. That's going to be the knob. The correct way would be to fix the mesh and either reprint the front plate, which is fairly easy to do, or the fan duct and make a mod to the fan duct, one way or the other. And like I said, it might be that we just order two V2.5s and this kind of gets shelved a little bit until we get back from Form Next. So, because it'll take a while for those parts to get in. Kind of depressing though. Kind of depressing. But yeah, I'm really liking the Anthead design. Just gonna look at this again and see if I can eyeball the angle. Just seeing if I can scrape this down just a little bit. And get it to align. Getting there. Now, does this mean that I won't go and still look at getting another 2 orbiters? No, I'm just going to see if I can make this fit, because why not? Another couple of I think that might have it right there. I think it is M3 by 20s to connect or screw that down. M3 by 12 button heads for the standard. These are going to be regulars. 30s, 50s, 20s. I mean, hell, if that's all it took was that much of filing, we'll be good. Here's some 12 button heads. If all it took was that little amount of filing, yeah. All right, just like I said, a minor little bit of filing. I could have also filed that tip right there on that fan front cover, and that's all that it took to do it. It come big time bitch side. So I did a little bit of filing to this front edge here of the orbiter mount. Could have done some filing to the back of that fan shroud, but we're sitting flat and flush. So we'll give that a shot. We'll go ahead and we'll mount our standoffs in our tool board. Now I think this does put them at a slight offset as far as the tool board goes. Because the motors themselves, maybe, no, maybe not. This does have different mounts for these boards, though I think I should be able to use the same mounts. What do I do with the board mounts? Once again, these are the standard Galileo mounts. So, what mounts where? Oh, that's not going to line up. So I will have to print 2 more of these Nighthawk board mounts to be able to do the wiring. But yeah, there's our Galileo tool heads. So we'll just need to do a tiny bit of filing once again to this front edge here. Just basically kind of round it over and down. And we'll be able to get that mounted. Edge over. We will have to redo the wiring over here. I'm just trying to make sure that the clearance, get the clearance. So it's not a whole lot of material that we're moving. We'll have to try out the changes once I kind of reroute the wires over here. And oh, there's the other PTFE tube that we'll need. We'll take this one apart and we'll reroute some wires. Probably going to be easier to clip these wire ties because we're going to have to add some more to them. And yeah, we'll give it a shot down under Maker. And what I'll do is I will go ahead and order a couple of Galileos. Or I'm sorry, not Galileos. Some Orbiter 2.5s. And that way, if I have any issues, I've got quote unquote spares at the ready. Eight's out first. And yeah, I'm hoping that we don't have any issues. I mean, the hot ends are the same. In this case, the extruder is going to be different. But that should just be calculating E-steps. And if your E-steps are good, it really shouldn't be any major difference. But I agree, you know, we definitely want to try and keep the tool heads as close to the same as possible. It does make things easier when they're all the same, especially when you're troubleshooting, because it's always going to be, well, is the issue the difference in parts or tool head, or is the difference in, you know, some other setting? Gonna go over there. This. Okay. So, let's see, we wanted to completely loosen this side. Give this one a crack so that we can kind of move things a little bit. This wire, a little bit more of a crack. This wire, we want to basically go down and around. Yes, high flow, or the hot end fan, we want to go, give me that. Why are you not giving me a screw? Thank you. This wire I want to pull kind of out, and then we'll take it down and around to the other side. Thank you. Basically bring it back up and around to the other side. We'll just take it off. Be easier. Take it completely off. So our hot end and thermistor is still going to come up to the left. This one I'm going to bring up, kind of just follow that channel and bring it out to the side here through that gap. And sort of basically like that, just kind of crossing it over. That back on there. Want to get the screw on the right side started. Making sure that we don't pinch those wires. And it's a little bit too tight, so I'll undo that. Now we don't have a wire or a screw on this left side. What we're going to do is take this wire, kind of run it into that gap, and make sure that we're going into that channel both behind this and in this gap in this spacer plate. What that's going to allow us to do is bring the wires down instead of up. And we're not crimping those wires, which we're not. That stuff down. So the hot end fan wires going to come out here on the side just like that. This wire is coming down. We'll be able to put our front shroud on. Those wires stacked. Tighten this in from the back. Make sure those wires are out of the way, meaning our hot end and our thermistor wires. This wire is going to have enough room to kind of sneak around right there. This wire is going to do the same thing over on this side, kind of right about there. And we'll put our side fans back on, making sure that we catch that little tab. Fan wire there, fan wire right there. Just got enough room to come around the top of the side fan. Pop that fan back off and put in our screws on the side before we forget. Don't know how critical that is, but if screws are there, they're meant to be there. Put this back on. At the end of the day, hopefully we're going to have 2 more tool heads done. Well, at least done to where we can be ready to wire. I'll have to reprint the rear board mounts, and then I can wire those up off stream, since you've already seen me wire those up before. By doing it this way, we keep the most amount of slack here. We should hopefully still be able to bring it around, plug it into the board, and we'll be good. Hot end fans and stuff come up. We'll be able to bring that directly into the channel and zip tie those on both sides. Same thing over here. Our hot end wires are good. And 3x8s go into the back. Hey, Stay Creeping, how's it going? Welcome in. We are troubleshooting. So we got our off stream. I extended the heater and thermistor wires for the other 2 tool heads, 2 and 3. I've got to disassemble these to get them done because the let me grab one of these. So this, while it is insulated wire, it's not, I'll say, bonded to the wire. So when you go to, just strip this type of wire right here, it just pulls the sheathing off the bottom of the wire down here. So what I wind up doing is pulling it up some, trimming it, and then you have to pull it back down here, because if you're trying to push it from up here, this wire is just going to bend around and it won't push down to the ceramic heater. So that's one of the, I'll say, pains in the butt with this stuff. So I've got to take basically 1 and 2 apart to do that, to extend those wires. And I'm not going to do that on stream. I'll do that off stream another day, maybe tomorrow night while we're not streaming. And also, I'm going to have to print 2 more of these rear plates that we use to mount the Nighthawk here. because the backer plates for the Galileos won't work. They don't line up right. So still a couple of things to do. Maybe we'll pull the wires out of this and we'll take the whole board off, put them over here and wire these two up. That way I'm halfway done to getting that one rebuilt. What are we going to do? We're going to put PTFE tube in. I was chamfered. That down on there. Three by 12 button head. So there we go. We'll throw some zip ties in here to keep these constrained a little bit after we get the boards on the back. We'll bring our other wiring out and around and through and under or whatever, however we have to do it to get our wires in. We'll also need to put in our back thing, our sensor. So let's see where we're going on our directions. Hey, Water, how's it going? Yeah, building was great. We had to break out the file. So this front edge of the Galileo 2 standalone fouls with the pretty edges of the fan duct here. So I had to file this both this way as well as at an angle like that so that it fits down in there nicely, but we got that done. The boards that I had printed for the Galileo don't actually fit. And so these I can't use. I'm going to have to print out these boards. Now, I have to take this apart to extend these. So what I'm going to do is see if I can't take the wires off, and then we'll basically undo these to the point where I can just take these boards off and swap them over. And whoever designed pH connectors, yeah, do not let me catch you in a dark alley somewhere, because they kind of suck. They're definitely a pain in the butt to get back out. There we go. Okay, so everything's disconnected from this board. Awesome, and I have to take the Nighthawk off in order to get to one of the attachment screws, so think these I just need to loosen because these are into plastic and it should still slide off once we loosen those. So I'm assuming you made it home safely, Waters? Okay, and like I said, because we're going to have to take the other ones apart, I'll print the new back plates and we'll get those squared away. You're excited for PCB Carolina tomorrow. Okay, I didn't know PCB Carolina was doing its thing tomorrow. So cool. The Fibra Seeker. That's on Friday. I mean, Mrs. Dragon's out of town, so technically, I mean, I still have that thing called work, but I can work from there. So as we mentioned at the top of the show or the stream, the words on stream are hard. The Optimus P1 is up and moving. We have pushed plastic with it. We're going to need to do a little bit of work on it still, but we're making progress. Part cooling fan, and part cooling fan is that one. Yep. So this is the one that's kind of a pain in the tuchus to get in. We need about another 4 millimeters to make it less iffy. This is our LEDs coming around, and LEDs go there. Is that going to make it? Just maybe. All right. LDO, give us 5 millimeters more on some of these wires and we'll be fine. 5 millimeters more. All I'm going to ask for. 5 millimeters. Those two are there. This is going to be part cooling. This is going to be hot end fan. This is going to be our hot end stuff. Hot end fan would be the second one across. Rewire that direction. Part cooling fan, 2-wire that direction. Need a couple of zip ties. Wrong zip ties. Zip ties over there, zip ties over here. And this one fan, which is this left fan, is going to be extremely tight. There's no easy way of getting it around there. We got to be careful when we're zip tying this that we don't that really needs to be extended, because that is kind of crazy. Just, there's no, like zero slack there. Okay, so do that. The white ones are a thermistor. The black ones are the hot end, which will get ferrule connectors. We also need to get our, whatchamacallit, the, I'm going to say probe, but it's not probe. The OptiTap sensor. Jeez. Getting words on stream get hard sometimes, folks. Where's the OptiTap sensor? RGB, 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 RGB. Box did I put the OptiTap sensors in? Base kit, that's not it. There they are. Now the wires that come with the OptiTap sensor are terminated on one end and not on the other. Right? So it would be made for you to terminate your own, and they're pretty long. The kit comes with some pre-made short wires. They're done in the same orientation, so it doesn't matter which side you put where. We're going to line this up, and we will mount that with, is it M3x6 or M3x8? Do that, mount that. OptiTap gets mounted with 2 M3x8 button head cap screws. We don't have those already out. They're going to be in the box over there, so we'll grab those. Or I can grab a couple from right there, one way or the other. I guess while I'm sitting here, I'm going to try and combine these other fasteners that I got sitting in front of me so they're out of the way. But I hope everybody's doing well today. I hope everybody had a great Veterans Day. If you're a veteran yourself, please feel free to let us know. I am an Air Force veteran, so I would be more than happy to shout you out as well. So dropping stuff again. So what we had? We had M3x8 socket heads. M3x30 socket heads. M3x40. Got M3x50 now. Some of these are just going to be straight up spares. Once we get everything built, we will go ahead and add things into the collection over here of spare bolts and nuts. M3x20s. M3x6 flat. I'm just going to set that to the side. Shims. A couple of other things. Those will be extras sitting over on the side for now. And M3x6 button heads to mount do that so we can mount off the tap on both of these, and we'll just now these are mounting into plastic, so tread gently and be prepared to stop so you don't strip threads or strip the plastic, as you are cutting threads as you're doing this. Make sure you're just snug. You don't want any wobble in that PCB. Where's the, oh. Why does this feel, this is actually sitting a little bit further back as well, because now I should have put the wire on first on this one. So the tool head will sit a little bit further back on this. I'll let you see what I'm talking about here in a second. Let me get this wire inserted and back on there, and then I'll hold the tool heads up side by side. Yeah. Hey, M3x6 in the ground. Easy to find. This comes around and left. Doing a bit of a crisscrossy pattern here. Okay. All of those in together. We'll put a zip tie on that to make sure that they stay put, but I'm going to put these front to front, and this is going to sit a little bit further back. Not by much. I mean, it's, was it like 2 mil? 3 mil? All right, 2 to 3 mil. So God, words on stream. The Galileo 2, because of the stack of the motors and stuff, it's going to sit a couple of millimeters back from everything, from the standard orbiters. Now, the pins and the pickup are going to be the same. It's just the where the actual board sits is going to be a couple of millimeters back. Now, with that said, the Orbiter 2 calls for 22 millimeter standoffs. Okay. I've got some fully threaded 20 millimeter standoffs underneath there. They're aluminum standoffs, so I could use those aluminum standoffs, and that would pull this board, you know, back forward a little bit. I just have to take things off and rewire it. Now, the other thing, this motor is way longer than it needs to be, so we'll need to look at this and match it to about that length, cut it, and re-terminate the Galileos. So, a couple of things that we'll have to do. We'll need to terminate these properly and get them installed, and then terminate our whatchamacallit wires over here and get them installed. We'll route these under these other wires. You come here. Go that way. We'll bring this around and we'll put a pH connector on this and get that installed. Once again, this is a thermistor wire, so it does not care about polarity. I will shorten this just a little bit. We'll have to put pH connectors on so that we can install that. I do have pH connectors, so that's not an issue. And then we'll figure out the lineage for this. We'll strip these down, put ferrules on them, and get those installed. But folks, it is 9 o'clock, and I'm about to call it done. Yeah, I'll continue to work on some of this wiring. Like I said, tomorrow, it'll just, it's wiring. I know it's boring. but we'll get this done. There, like I said, there will be some slight idiosyncrasies between the tool heads because of some of the choices that we have made. But we can always make some other choices, such as make the decision to switch everything over to orbiters instead of two orbiters and two Galileos, right? We have some options and we can exercise those options. But I do appreciate everybody being here. I hope everybody is enjoying the build process so far. This is, like I said, going to be a long series in the build because it's very complicated. It is a very complicated build. But we're going to get there. Complicated because of the number of components that we're dealing with, not necessarily that it's that it is a complicated concept. It's just more along the lines of doing the same thing over and over and over again until we're done. But yeah. So with that said, folks, oh yeah, definitely multi-headed boron. Definitely. I'm glad it helps. It helps me work my way through all this as well. So, hey, Pile 3D, how's it going? Yeah, it takes a long time to build these. And basically, like I said, we're going to be stripping this down to, well, we'll see. We're going to do the LDO, and there's a part of me that wants to try and rebuild it without, no, we're going to have to drop the gantry. I watched somebody try and do it without dropping the gantry and just doing one corner at a time. The chances of that gantry not being twisted or skewed, it's just going to be too much to chase. So we'll go ahead and just swap things over. Now what I'm going to do is, because I've got some grease in here, I think I'm going to take this grease that LDO gave me and just squirt it the rest of the way in there. So we'll have all of our excess grease in one place. It looks to be the same type of grease, like an EP2 based grease. So we'll have our extra little grease container. But thanks for being here, everybody. Like I said, I'll work on the wiring here and getting things finished up and fitted up. I think we're making some good progress, though. Everybody, take care. Have a good and wonderful day. Let me see who we can raid over into. Polymaker Joel guy is up. Who else we got? We got Polymaker Joel. Jang is doing some stuff. Layer by Layers having his talk show tonight. Who is he? Oh, he's talking with 3D Print SOS with Fader. Right, we're going to jump over there. Go chat with Layer by Layer and Moji, and they've got 3D Print SOS, aka Fader, on there. So thanks again, everybody, for being here and sticking through this build with me. It's going to be fun. You guys have a great one. We'll be here Thursday night. Saturday we'll see, just because I've got to pick up Mrs. Dragon from the airport, or from the train station, and be ready to get to the airport on Sunday, because we're heading over to, goodness gracious. We're heading over to Frankfurt, Germany for Formnext. So, yeah, there we go. Everybody, have a great night. Have a great day. And I will see you all on Thursday. Bye now. And if you're watching this over on YouTube at a later time, thank you for sticking around. Hopefully you like what you see. Be sure to hit that like button down below. While you're down there, hit the subscribe button and click on the bell to be notified of future videos. That way when we go live or when we post new videos, you'll be able to see those. And speaking of new videos, YouTube's going to be suggesting one right over here. You all have a great day. Bye now.